Hello. In previous units, we've talked about linear functions, but there are other functions that are nonlinear, and this unit is going to be, we're going to be exploring one of those nonlinear functions, and those functions are called exponential functions. Okay? So an exponential function is a function of the form y equals a times b to the x. Notice that my x variable is in the exponent. That's what makes it an exponential function. And I have y equals a times b to the x where a cannot equal 0, excuse me. B has to be greater than 0, and b cannot equal 1. Okay? So those are some parameters that we have to make sure when we are working with our exponential function. A can't be 0 because if a was 0, this whole thing would be 0. B has to be greater than 0 because, once again, if this is 0 or negative, it's going to be weird. And then if b can't equal 1 because if b equals 1, then it's just going to be a times b, which is going to end up being a function. So anyway. Exponential functions are nonlinear functions, as I just said. Nonlinear. And so let's look at what we had before in terms of linear functions and exponential functions. So when I have a linear function, for instance, y equals 3x plus 2, I can figure out y values for any given x simply by substituting them in, and then I can see what's happening. So, for instance, if x equals negative 2, this part here would be negative 6 plus 2 would end up being negative 4. If x were negative 1, this is going to end up being negative 1. This is going to end up being 2. And then 3 times 1 is 3 plus 2 is 5. And then this is going to be 8. Okay? Whereas with an exponential function, once again, notice that the exponent, the x is in the exponent here. So I'm going to start off where x equals 0 and then work my way around. So anyway, so I'm going to use the same values here, negative 2, negative 1, 0, 1, 2 for my x values, but substituting them into this function, y equals 2 times 3 to the power of x. If I substitute 0 in for x, through anything to the 0 power is 1. So 2 times 1 is going to end up being 2. Okay? Now substituting 1 in for x, okay, 3 to the power of 1 is going to be 3. 3 times 2 is 6. Substituting 2 in for x, 3 squared is 9, times 2 is 18. And then now you can see that when I substitute the negative 1 in here, it's going to be 3 to the negative 1. Remember, 3 to the negative 1 is the same as 1 over 3, so this is going to end up being 2/3. And then 3 to the negative 2, if you remember, 3 to the negative 2 is the same as 1 over 3 squared, which is 9, so this is going to end up being 2/9. All right, so I want to analyze this a little bit before we move on to writing a rule for the function. Notice that for my linear functions, when my x's increase by 1, all of my x's are increasing by 1. Whoop, should put 1 there. All of my x's are increasing by 1. My y's are increasing by 3. Increasing by 3 means it's adding 3 to the next one. All right? So we can see this, that when my x value is 0, y is going to be 2. It's going to be this one here. I'm going to change my color to blue. This one here is my y-intercept, and what do you know? It's where x equals 0. And this one right here, the reason why it's going up by 3 is because of the slope is making it go up by 3. Okay? Analyze that one, where these numbers come from and how they relate to our table. Let's check out this one. Notice that as I'm going to change back to red, make my weight a little bit smaller again like I did before. And so notice that when my x values are increasing by 1, Now I'm going to start here again. Notice that my y values aren't increasing by 3. They are being multiplied by 3. And they'll go from 6 to 18. It's being multiplied by 3. And the same thing here. If I have 2/3 and I multiply it by 3, I'm going to get 2. If I have 2/9 and I multiply it by 3, I'm going to get 2/3. So analyzing this one here, switching back to blue, notice that as my x values are increasing by 1, now my y values are being multiplied by 3. That's what this 3 is coming from here. Okay, and also notice that when my x value is 0, my y value is 2, and that happens to be this value here. It's always going to be the case for exponential functions. Okay, so in knowing that type of relationship, we should be able to come up with how to write our rules when we're given a table. So come over here, and so for example, notice that I have this is increasing by 1 plus 1. This is increasing by 1 plus 1, increasing by 1 plus 1. So I know my x values are increasing by 1, which is fantastic. My y values are being multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. So because of that, I look here, I can see that this right here, where my x value is 0, I'll come back up here so you can see this, where my x value is 0, my y value is going to be what this thing is here. So it's going to be y equals, in this case, it's going to be 8. And then notice that it's going multiplied by 3 here, so that's what this one's going to be, times, and it's going to be 2 to the x. So that's how we come up with those. Okay? Looking at this one, so I'm going to put a circle around this so we can see that that is the rule for this one, my variable x is there. Once again, increasing by 1, increasing by 1, increasing by 1, increasing by 1, so I know that part is cool. Here, I'm multiplying by 3 to get from 3 to 9, multiplying by 3 to get from 9 to 27, multiplying by 3, multiplying by 3. So once again, I can see right here that my value for y when x equals 0 is 27. So this could be y equals 27. And then it's going up by 3 times, or multiplies by 3, 3 to the x. That is my function. That is my equation for this function, or my rule. Remember, equation and rule are the same thing. So that's how we come up with the rule for it. Now, what we're going to do is also see what happens when we graph our function. All right, so in this case, we want to graph the function y equals 2 to the power of x. All right, and then we're going to identify the domain and range. All right, so let's do that first. Once again, I always like starting with 0, but have some negative numbers and positive numbers. But if I start with 0, if I put 0 in for here, 2 to the 0 power, anything to the 0 power is 1. So I know that that's going to be 1. If I put 1 in for here, that's going to be 2 to the 1, which is 2. If I put 2 in for here, 2 to the 2 is 4. If I put negative 1 in here, I'm going to get 2 to the negative 1, which is just 1 half. And then 2 to the negative 2, I know is going to be 1/4. So these are 1/4 and 1/2 and like this. So here I made my table. Boop. Now I'm going to plot my points. Is going to be next. Negative 2 1/4 is going to be about right there. Negative 1 1/2 is going to be right about right there. 0 1, 1 2, and then 2 4. Notice that my graph is going to go up really quickly, and it's also going to come down here. And what do you think? Will the graph ever cross the x-axis? So think about it. As my x values get smaller and smaller and smaller and smaller, get bigger negative numbers, will I ever end up with y being a negative number? No, I won't. So it will never cross the x-axis. Graph never crosses x-axis. Okay, but here it's going to go up, 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 on forever and ever, yeah? So that means my domain, remember, can be any x value, or what my x values can be, because it goes on forever here. And yes, it goes on forever up, but it's also going out. So I know my domain is going to be all real numbers. Whereas my range is going to be the set of all y such that y is going to be, now it can't be anything negative, so I know it has to, anything greater than 0 then, because it can go on forever up there, like that. Awesome. So that's how we graph our exponential functions as well. So domain, range, how to graph them, how to come up with our equation for exponential functions, and that's how we do it. So enjoy. Bye.